All right, guys, let's tackle this here. Hey, for tomorrow, well, actually, we're going to do this one in class, so don't worry about this one. This one's going to be in class. All right, so we're going to talk about probability rules. This one's not going to be too long. So when we're talking about probability, don't forget reading the book is really crucial, guys. And I know some of you do, some of you don't, but I would suggest that you do it. But we're going to talk about sample space. And so sample space is the set. Let me get this where I need it here. Is the set of all possible outcomes. So in other words, the idea of, let's say, flipping a coin. You have two options. You're going to either get a heads or, tails. Those are your two options. So your sample space is either the event is a head, that's an odd outcome, or it's a tail, that's an outcome. Dice, 6 sides for a dice. So when we take that piece, we're looking at this idea of a model. So basically a model is this. It's the sample space and the probability. So in other words, let's take a dice. So let's take a 6-sided dice. Okay, so if we take a 6-sided dice, we know that we can get a 1, a 2, a 3, a 4, a 5, and a 6. So those are all the possible outcomes. I can roll a 1, I can roll a 2, I can roll a 3, I can roll a 4, and I can roll a 5. And that right there is going to disappear. And I can roll a 1. Okay, so now if I look at it and I say, okay, if I kind of draw a table, and I'm not going to attempt to draw a table for you guys. I'll just kind of do this. You guys can finish it off because my vertical lines are horrible. So if I roll a 1, the probability, so this would be the probability. This is the event. If the probability is of getting a 1, it's 1 out of 6. Okay? And this one is 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6, and 1 out of 6. For a total probability of the sample space is equal to 1. So these all have to add up to 1 here. Okay? They all have to add up to 1. Moving some things around. All right? So that's just kind of the idea. So this is a probability model. It always gives you the events that we're looking for and a probability. So like if we're going to do like a coin flip, you have the event and you have the probability, and it's either heads, it's tails, and the probability is 0.5 and 0.5. And the probability for this entire sample space is 1. That's one of the properties of these types of things. All right, so what's an event? An event is any collection of outcomes from a sample space. Sample space. So in other words, a coin has 2 of them. A dice has 6 possible events. So like rolling a 1. Rolling a 1 is a possible event, okay? So if we're looking at the idea of probability models, this is what they're talking about. So let's look at a probability model. So remember, a probability model is up here. It says, hey, let's look at a distribution of what this could possibly be. So if we look at this, and we're going to do 3, you're going to flip a coin 3 times. So that we'll just start with possibility. You're going to have heads. You can have 3 heads, and then you can have a tail and 2 heads. You can end up in this order: heads, tails, heads. Or you can flip a coin and get heads, heads, tails. And then you can start working your other way around where it's tails, tails, heads. And then it's tails, heads, tails. Or it's heads, tail, tail. Or it's tails, tails, tails. So we have the possibility for a probability model of 8 outcomes. So if you count them across here, 2, 3, 4, 5, 6, 7, 8. So those are the possibilities for the probability model. Okay. So each one is 1 in 8. So if I looked at this, each one of those events, the probability of any of the events, is equal to 1 out of 8, according to this probability model. All right. Now, what they want is they want the probability of at least 1 heads. Okay? In 3 flips. So, we're going to look at this and go, okay, well, how many of them have at least 1? So if I look at this, I'll change colors on this. We'll go and let's use blue. I like that blue color. So we're going to do, we know that there's 1 there, there's 1 there, there's 1 there, there's at least 1 there, there's at least 1 there, there's at least 1 there, and there's at least 1 there. At least 1. So what's the probability? The probability is 7/8. Okay, because we added up all the probabilities. All right. So let's move on to the second part here. Okay, we've moved on to page 303. What does it mean if 2 events are mutually exclusive? That means that the 2 events cannot, period, have an outcome in common. So in other words, you can't have a heads and a tails. So let's take a coin flip. So basically, they cannot occur at the same time. They never can occur together. So if I flip it once, I have heads or tails, never together. That's the idea of mutually exclusive. So the idea of mutually exclusive is if you're choosing a male or a female, you get a male or a female. The choice isn't together when you're picking things, and there's no outcome that's the same. So that's the idea behind mutually exclusive. They can never happen together. All right, so probability rules. Here we go, guys. Almost done. I may have to add a little bit of space to this. All right, let's just add some space to that. All right. So let's look here. So number 1, 5. So the first principle is this, is that any event's probability is between 0 probability and 1. In other words, this is very unlikely and this is likely. Oops, likely. Can't have more than 100%. So the probability is between 0 and 1. It can be 0.5 for 50-50. That's rule number basic rule number 1. Basic rule number 2, the sample space probability equals 1. In other words, it all adds up to equal 1. The probability of the sample space is always equal to 1. You got to add them up. If it doesn't add up to 1 for the sample space, it is not a valid or a legitimate probability model. All right, so let's look at this one here. So the probability of an event. The probability of any event is always equal to the outcomes for that event divided by the total in the sample space. So we'll take a coin. There's 2 possibilities for a coin flip, right? So there's 2 total possibilities for a coin flip. And so the probability that it's tails is 1 possible outcome for the total of 2. So that's why it's 0.5. And then that 0.5 falls into the idea that it's between 0 and 1 here. And if we add the other idea of of heads, that's 0.5, and that adds up to equal 1. So the rules, these are basic probability rules that just kind of make a little bit of sense when you start looking at them. All right, so the complement rule. It's called the complement rule. Complement, meaning kind of the opposite is happening. So the complement rule is always this, is the event's complement, put a little C up there for complement, is always 1 minus the probability of the actual event. So, in other words, what's the probability of not getting tails? So what's the probability of the tails complement? Meaning that what's the probability of getting heads? Well, it's 1 minus the probability of getting tails, which is equal to 0.5. That's what they mean by the complement. What's the probability of getting the other thing you're looking for? So number 5, the last one. The probability of, actually, let's cross that out. The probability of A or B is always equal to the probability of A plus the probability of B. Okay? All right. So let's just look at this piece right here. So the first thing is we got to show that this is a legitimate probability model. So we're right here. We're looking to see if it's a legitimate probability model. So remember, the probability of the sample space has to equal 1, which means that for this particular case, it's what's the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability, probability of 5. So if we add those probabilities up, we're going to get 0.233 plus 0.183. I'm getting those numbers, guys. Getting those numbers from right here. So if we add all these up and we go ... we're going to get pretty close to 1.0, which is going to be, it's a legitimate probability model. It has a sample space. It explains all the outcomes, and it has their probabilities with them. And then the sample space probability is equal to 1.0. So then we look at this and say, oh, find the probability of that a student scored 3 or better. So find the probability that the score is greater than or equal to 3. Well, that's the probability of those. So it's the probability that you get a 3 plus the probability that you get a 4 plus the probability that you get a 5. Okay? So I don't have my calculator, but you would add 235 plus, whoa, what's going on here? 0.224 plus 0.125, and then you'd get that answer right there. Whatever that answer is. I don't know. I don't have my calculator. Remember, I left it at home. So that's the idea here. All right. So then on the other hand, this is, C is a complement. Find the probability that chosen didn't get a 1. So that means he got everything else. So what's the probability that the score is equal to 1 and it's its complement? So we're going to say the probability of equals 1 minus the probability. Where's my eraser? Minus 1 of the probability of 2 through 5. So you would take and add up all of these. Oh, let me go backwards. That didn't work. I did it backwards. So what's the probability that they didn't get a 1? It's the probability. It's 1 minus the probability. Sorry, guys. The probability that they got a 1. So it's 1 minus 0.233, which is going to be, I can do that one close to my head, which is going to be approximately 0.667, I think. If you do the math, no, 0.777. Where's my eraser? There it is. 0.767. Yeah, 767. I think. Check on your calculator. But that's the idea. All right, so tonight, when you're dealing with simulations, remember, you got to do at least 10 trials. We've got these problems to work on. It's homework number 30. Don't forget to attach them. And we will see you guys soon. And stop sharing.